Hi, good day. Welcome back to our class in Chemistry 100B. Today, I'm going to discuss about the expressions of a solution or the units used to express the concentration of a solution. To recall, a solution is defined as a homogeneous mixture composed of the solute and the solvent. The solute is that substance to be dissolved, and usually it occurs in lesser amount, while the solvent is that substance that dissolves the solute, and it usually occurs in larger amount. Now, what are these expressions of solutions? We have number one, the percent by mass. This percent by mass is actually a ratio between the mass of the solute and the mass of the solution times 100. Now, since we know that a solution is composed of a solute and a solvent, we can also modify this percent by mass formula by stating that percent by mass is equal to the number of grams of the solute divided by the sum of the number of grams of solute and the number of grams of solvent times 100. For example, if you are given the number of grams of solute and the number of grams of solution, you can immediately substitute the number of grams of solute and the number of grams of solution to the formula, then multiply it by 100. But if you're given the number of grams of solute and the number of grams of solvent, therefore, you have first to get the sum of the number of grams of solute and the number of grams of solvent, then use this as the divisor in dividing the number of grams solute by the total number of grams of solute and solvent. Then multiply it by 100. In the example that I gave you in your notes, you notice that I gave there the number of grams of the potassium chloride and the number of ml of the solvent water. But in the formula, it states that it is percent by mass equals the number of grams of solute divided by the number of grams of solute plus the number of grams of solvent. So how do you convert the number of grams of the solvent water? Since it is given there that it is 120 ml, we have to convert that 120 ml to grams. So just multiply that 120 ml by the density of water, which is 1 gram per ml. So you can cancel out the ml unit, remaining the number of grams. So you can add now the number of grams solute plus the number of grams solvent. You use this as the divisor to the number of grams of solute, so that you have the answer there stated as the percent by mass is 0.83%. Another expression of the concentration of solution is the percent by volume. This is defined as the ratio between the volume of the solute and the volume of the solution times 100. Or it can be modified as the volume of the solute divided by the sum of the volume of the solute and the solvent times 100. Now, if you are given the number of ml of the solute and the number of ml of the solution, so you can immediately substitute these values to the formula. Then divide the number of ml of the solute by the number of ml of the solution times 100. But if you're given the number of ml of the solute and the number of ml of the solvent, then you are going to get the sum first of the number of ml of the solute and the number of ml of the solvent. With the sum of this number of ml of the solute and the solvent, you use this as the divisor to the number of ml of the solute, then multiply it by 100. In the example that I gave you, I gave here a solution made up of the rubbing alcohol and the water. So, since you're given the number of ml of the solute and the number of ml of the solution, so you can substitute immediately the number of ml of the rubbing alcohol, which is known as the isopropyl alcohol, and the number of ml of the solution, then multiply it by 100, giving us here the result. The percent by volume of that rubbing alcohol is 70%. This concentration of the rubbing alcohol, by the way, which is 70%, is actually the best concentration to be used as a rubbing alcohol as well as a germicidal or an antiseptic. Another expression of the concentration of a solution is the mole fraction. In the mole fraction, you are going to get the ratio between the mole of substance A and the number of moles of substance A, substance B, substance C, and etc. As long as how many number of substances there are in the mixture or the solution. For example, if you have two substances being mixed and you are asked to get the number of moles of these substances, and if you are asked to get the mole fraction of this solution, then you have only two substances being mixed, let us say substance A and substance B. So for the mole fraction of substance A, it would be number of moles of substance A divided by the sum of the number of moles of substance A and substance B. But if you're going to get the number of moles of substance B, it would be the number of moles of substance B divided by the sum of the number of moles of substance A and substance B. If you have three substances being mixed in a solution, therefore, you will add, let's say, the number of moles of substance C divided by the sum of the number of moles of substance A plus substance B plus substance C. Take note that you are asked to use the number of moles. So, how do you get the number of moles? That is, if you are given substance A in terms of number of grams, so just multiply this number of grams by the reciprocal of its molecular mass or atomic mass, so that you can cancel out the number of grams, leaving behind the number of moles. In the example that I gave you in the notes, you are given there that the 25 grams of ethyl alcohol is being dissolved in 60 grams of water. So, because you are given the number of grams of the ethyl alcohol, you have to know what is the molecular formula of ethyl alcohol. Now, ethyl alcohol has the formula C2H5OH. Therefore, when you get the molecular mass of the ethyl alcohol, it would be multiply carbon by 2, hydrogen by 6, and oxygen times 1. So that you have it there, the molecular mass of the ethyl alcohol is 46. So getting the number of moles of the ethyl alcohol, you have 25 divided by 46. And you have the number of moles is 0.54 moles of C2H5OH. And since you are given also the number of grams of water, which is 60 grams, then multiply this number of grams by the reciprocal of its molecular mass, which is 18. So you have it there, number of grams, which is 60, divided by 18, will give us 3.33 moles of the water. So to get the number of moles of the ethyl alcohol, if we let ethyl alcohol to be our substance A and the water to be our substance B, therefore we have the number of moles of ethyl alcohol, which is X sub A, equals 0.54 divided by 0.54 plus 3.33. And if we're going to get the number of moles of the water, it would be X sub B equals 3.33 divided by 0.54 plus 3.33. So you get the number of moles of the ethyl alcohol and the water. Another expression of the concentration of solution is the molarity. Now, molarity is defined as the number of moles of solute divided by the number of liters of solution. So you have to be very careful that the divisor here is liter of solution. It's not ml of solution, because you have it there, moles per liter is the final unit for molarity. So that if you are given the number of grams of the solute and the number of liters of solution, so what are you going to do first? You have to convert the number of grams of the solute into moles of the solute. Then divide it by the number of liters of solution. So simply substitute the number of solution into the given formula. But if we are given the number of grams of solute and the number of ml of solution, so what are you going to do? First, you have to convert the number of grams to number of moles solute and the number of ml solution to number of liters of solution. So we know that in 1 liter, there are 1,000 milliliters. So that is the conversion factor that you're going to use from an ml to a liter. Another expression of the concentration of solution is the molality. In the molality, this is defined as the number of moles solute divided by the number of kilogram solvent. This molality is given the symbol small m to differentiate it from molarity, because both starts with letter M. For molarity, it is given the symbol capital M. But for molality, this is given the symbol small m. Now, I said a while ago that molality is a ratio between the number of moles of the solute and the number of kilograms of solvent. So, if you are given the number of grams of the solute, so you have to convert it into moles solute. And if you are given the number of liters of the solvent, you have to convert this number of liters of solvent into kilogram solvent. So how do you convert this number of liters solvent into kilograms? You have to multiply the number of liters by the density of this substance, converting it into number of kilograms. Another expression of the solution is the normality, and this is given the symbol N. Normality is defined as the number of equivalent solute divided by the number of liters solution. Normality is defined as the number of equivalent solute divided by the liters of solution. Now, how do you get the equivalent solute? This is dependent on the kind of substance the solute is. If the solute is an acid, then you are going to get the molecular mass of this acid divided by the number of hydrogen ions contained in the acid. For example, if the acid is hydrochloric acid, so get the molecular mass of the hydrochloric acid, that is 36. Because you have hydrogen is 1 plus chlorine is 35, so you have 36. Divide it by 1 because there is only one hydrogen ion in hydrochloric acid. So for hydrochloric acid, the number of equivalent solute will be the molecular mass of hydrochloric acid divided by 1 because there is only one hydrogen atom in hydrochloric acid. But if you have sulfuric acid, since in sulfuric acid you have 2 hydrogen atoms from the formula H2SO4, so getting its equivalent is you have to get the molecular mass of the sulfuric acid and divide it by 2 because there are 2 hydrogen atoms in sulfuric acid. If you have phosphoric acid, since the formula of phosphoric acid is H3PO4, so in getting the equivalent solute for phosphoric acid, it will be the molecular mass of the phosphoric acid divided by 3 because there are 3 hydrogen atoms in phosphoric acid. But what if your solute is a base? So it is also the same, but this time we are going to consider the number of hydroxyl ions found in the base. For example, if you have sodium hydroxide, then getting its equivalent solute for sodium hydroxide, it will only be the molecular mass of the sodium hydroxide divided by 1 because there is only one hydroxyl ion in sodium hydroxide. But if you have magnesium hydroxide, then in getting the equivalent solute for magnesium hydroxide, you get the molecular mass of magnesium hydroxide and divide it by 2. But if your solute is aluminum hydroxide, we know that in aluminum hydroxide there are 3 ions of hydroxyl, so the equivalence for aluminum hydroxide will be the molecular mass of the aluminum hydroxide, divide it by 3. Now, if the solute is a salt, so it's not a base, it's not an acid, but a salt. So in this case, you are going to divide the molecular mass of the salt by the total number of positive ions contained in the salt. For example, the salt is sodium nitrate. Now in sodium nitrate, the number of equivalents will be the molecular mass of the sodium nitrate divided by 1 because there's only one positive ion in sodium nitrate, and so on and so forth. Now, how do you use this in the formula? If you are given in a problem the number of grams of the solute and the number of liter solution, your problem there is how to convert the number of grams into number of equivalents solute. So with that equivalent solute that we have computed for the acid, the base, and the salt, that would be your conversion factor to convert the number of grams of the solute by multiplying it by the reciprocal of the equivalent weight so that you can cancel out the unit grams. So that would be all for today. I hope you have understood our lesson and discussion. Anyway, I provided you with the notes. Just refer to your notes that I sent you. And I will be sending you an exercise for this lesson. That would be all. And this is your teacher, Professor Nesitas Ruiz of Holy Name University.